Hello, everyone, and welcome to the demo of Llama 3.2 in Amazon Bedrock. So as you all know that the Llama 3.2 from Meta has been released recently on Amazon Bedrock, and it is a new generation of vision and lightweight models that can even fit on the edge devices and helps you to get more personalized AI experiences. The Llama 3.2 comes in in four variants: the 11B, 90B, 1B, and 3B, and which is basically including a small and medium-sized vision large language models, which are 11B and 90B variant, and the lightweight text-only models, which are 1B and 3B, that supports image reasoning and on-device use cases. So let's take a look at the one of the 90B models and its vision capabilities as a part of the demo on Amazon Bedrock. So for the demo, we are going to use the Amazon SageMaker Studio over here, and where we are going to use the Bedrock SDKs, and also we'll be using the Llama 3.2 90B model. So as you can see in my Amazon SageMaker Studio, we will have the Boto 3, the Mac for using the Bedrock SDKs, and also the Matplotlib and Pillow to just visualize the image that we are using on our Amazon SageMaker Studio. So we are going to import these libraries, which are Boto3, the pillow image, the matplotlib to visualize, and then some of the Boto core exception class based on your requirements. In the next cell, we are going to initialize our model ID. In this case, we are going to use a cross-region reference um, model ID over here, which is the Llama 3.290B instruct, and then we'll also initialize our Bedrock runtime client. So let's run the cell. The second function is basically a helper function, which is going to help us to visualize or see the image onto our studio notebook. So let's initialize that. The next function is the main function, which will be used to pass the query that we are going to test and then pass it on to the Amazon Bedrock for the Llama 3.290B vision model to analyze it. So in this case, we are going to have the message payload format, which will have a role and the content. And in the content, we are going to pass the image as the byte. And then we'll also pass the text, which is having the user message and which is nothing else but the query that we are going to pass. Then for the demo, we are going to use the convert stream from our Bedrock runtime client, which will take the model ID, the message format that we just discussed on the top, and then some of the inference config. And you can always change your inference config based on your requirement. And once the information is coming back from the streaming, we are going to extract and print the streamed response text in real time. So let's initialize this function. The next is basically we are going to load up our first image, which is basically a sample entity relationship diagram from a sample database. We have a couple of tables there, and then we will take a look at it that how the Llama B90B vision model will be able to interact with it. So let's initialize this. And let's take a look at the image. So this is the function that I was talking about, the show image function. So as you can see, we have student, courses, departments, professors, enrollments, and then there are some relationship to it. So let's run the first query. So we're going to query that in this entity relationship diagram, how many database table do you see? So let's run this, and in real time, you're going to see that it says that there are 5 tables: courses, departments, professors, enrollments, and student. The second query we're going to see is that if I need to find all students enrolled in computer science course, which table should I see? Only provide me the table's details. You can always change based on your requirement, but for the purpose of the demo, we are going to use this prompt. So over here, it's going to analyze it that to find all the student, we have to look at the enrollment, courses, and student table, which is right because the student information will come from the student table. The courses that they are enrolled into will come from courses and enrollment table. The next query that we're going to run is that we need to find all student running generative AI course in the machine learning department. So which table we should see, and then only provide me the table details. So let's run this prompt over here. So now it is going to analyze it that we need to look into the courses to find the course ID, and then the department, which is machine learning department, and of course the students and the enrollment. And then it's giving us a little bit of more details on what can be done through the relationship. The next image that we are going to load up is basically a reference architecture image, which is basically from one of our IoT reference architecture for camera as a service. And let's analyze this image using the Llama 3.2 model. So let's ask the first prompt, which is what does this architecture shows? So as you can see, it says this architecture shows an IoT enabled cameras to generate live video feed and machine learning inference that can be consumed by an end user. And you can change your prompt based on what your needs are. The next query that we are going to do is basically list the names of all the AWS services in this image. So as you can see over here, it's going to list down all of the different AWS services that it's able to find into this particular image. The next one is basically an interesting one where, because let's say if these are reference images, these are only existing into the image format. And let's say you want to extract this information and store it into your backend so that you can search. So let's do that, and let's see the capabilities of doing entity extraction and then requesting the large language model, or Llama 3.2 in this case, to give the output into a JSON format. So what we are going to give a prompt is that I want the large language model Llama 3.2 90B to extract the title, description, steps into a JSON format, and then also, getting all of this, providing more information that we need to store this information in a database for further use in a search application and return the JSON file as the output. So let's run this prompt. So as you can see over here, it starts giving the output into the JSON format where it is giving me the title, the description, and the steps. So as you can see over here, the title is coming from here, the description is coming from this place, and then all of the steps that you can see over here, like 1 to 11, it will be listed into the streaming response. So as you can see that it is working on it and giving back into the JSON format, which eventually you can take it, parse it, and then store it into your downstream system, let's just like a database or any other search application, so that you can easily search with this. So you can get more creative by even adding more details to it, that different AWS services. So yeah, so this is the demo that I wanted to show you today, to look into the vision capabilities from the new Llama 3.2 model from Meta, which is now available in Amazon Bedrock. So I would highly encourage you all to go to um, Amazon Bedrock and then start playing around with these models, where Amazon Bedrock makes it much more easier for you to try out these models onto their playground and then see what other capabilities that you can explore. So thank you so much for watching, and happy building.